Hello and welcome to CG Visuals, my name's Zach, and today we'll be having a look at the water category within Trapcode Elements. This tutorial is part of a series. Previously we had a look at creating airbending, earthbending, and also firebending effects using Trapcode Elements. To effectively follow along with this tutorial, you will need to re-download your copy of Trapcode Elements to get access to the free version 1.2 water shaders update, which will be featuring in this video. So without further ado, let's get started. Okay, so once we've opened up After Effects, the first thing we'll go to is File, Open Project, navigate to the Trapcode Elements water folder. That will be version 1.2 when you re-download it. We'll go to the flowing water ball manipulation. There are a few projects that have the tag manipulation in the title, and that just indicates that they are a 3D water volume that can be manipulated. So if we scrub forward through the timeline here, we'll get a realistic idea of what this is like to work with. I'll keep the caching times roughly as they are. As you can see, when we first start off in the export comp, we have this placeholder background here. It really comes to life when you add in a live action plate, as the reflection comp uses the footage to generate the refractions and the reflections. So if we go to the particles comp, this is where we'll make all of our adjustments and change the animation. But to start off, we'll just have a little overview. See, we've got this grid, a proxy simulation, which is always highlighted in blue and is set as a guide layer, so it can never be accidentally rendered. And this just allows us to scrub through the animation a little bit faster. Every project has this placeholder animation set up, sort of like a shelf tool, but of course it is designed to be completely customized. As this is a 3D volume, we have this scene light, which we can use to match the lighting. This will dictate which side of the water the specular highlights will be most visible on. And of course, being a 3D scene, we have our camera controls. You may notice this is a parent camera. That's because if we unhide the layers, there are some other projects that are dependent on that camera. For example, this water droplets comp, if we expand this, we'll see that there is a child camera. And all that really means is that if you were to 3D track the scene, you just want to copy your tracking data into the parent camera, or if you don't want to do that, you can always just copy the new camera you've created into those dependent projects, which is usually what I do. I'll track the footage and just duplicate the camera into those other projects. And you can always tell that if it's a parent camera. So we can rotate around the scene here, it's very interesting. So the next thing we have is this emission locator. It's the same in every project. The main particle rig is controlled by this one null object. Now, in order to set up our custom animation, you've probably noticed me doing this before. I like to create a red solid. Red, I think, is just the default color, but if you asked people to select a color off the top of their head, most people would choose red instinctually. So we'll just go and name this an emitter reference. Make it a 3D object, and we'll just pick whip the position to our emission locator. A simple red solid doesn't take very long to render, so this way we can focus all of our time making countless adjustments to the animation. We'll just make sure this 3D layer is not affected by lights. Some of the projects have different frame rates. For example, a very fast moving effect might have a frame rate of 50 to allow for extra frames to interpolate a smooth motion. Therefore, we'll set our frame rate to 50. So this is the placeholder animation. There's no need for you to use this. In fact, what we're going to do is completely start from scratch with the animation. Before we do that though, I think it'll be helpful to actually see our background footage that we're going to be working on, as that will help inform the animation. So I'll bring in this stock footage. I like to reinterpret the footage to be the same frame rate as the comp. Not necessary, but we can do that. We'll resize it. And now we'll re-enable our mission locator here so we can get our control handles. So the concept for this movement that I sort of planned or imagined is I want the water to emerge from the center of the screen. I want it to come out through the water, and then I want it to immediately jet off to the side, fly back in Z space to make it a bit more interesting, zip across the screen. So I'll just loosely plot out these keyframes. Then I want it to sort of hover for a second, act like it has some momentum, and then quickly zip over and splash back into the water. So this is what it looks like when we just plot down our keyframes. So obviously it doesn't quite have that finesse that we're looking for. So a good way to start is to go keyframe interpolation and set the options to continuous Bezier. That will make sure we have all of the handles, allows us to adjust the path. We can alt left click, adjust the overall timing. And if we go to the orthographic views, we can just make sure that something sensible is happening from the top down view. We can use those dots on the green line there as an indicator for how fast or slow it's going to be. So if between keyframes the distance between the dots radically changes, that would indicate it'll be accelerating. So after quite a bit of tweaking and little adjustments, I came up with this motion that I was fairly happy with. The idea is just to try and get something that seems quite fluid. You can see what's happening there in the top-down view. We can also add a wiggle expression to the animation as well. So sometimes if you add an extra layer of animation, we'll just get a more interesting movement as well. And then I think what we'll do is we'll re-enable our proxy simulation, just see what exactly is happening now, so we can see whereabouts in Z space the water is emerging. So I think we need to make a few other adjustments as well. We can shift this entire animation over to the left a little bit. That will be easier than adjusting all the keyframes. The water doesn't quite start low enough, so if we enable the background just temporarily, we can make some. We can also adjust this grid as well. So this grid is actually the floor. It's where the particles will interact with, and it will also obscure the water. So if we lower the floor, we'll also lower the initial keyframe just to try and get the water to properly emerge. And I think we'll adjust these keyframes at the end a bit, since we are going to have this big ice blast towards the end. We want to make sure the water is impacting sort of the center of that body of water there. Have another quick look at this. Doesn't take any time at all to make these changes. It's only when we enable our motion blur enabled volume of water that things will slow down. So We can make countless iterations here and just focus on refining this animation. It's very easy to do. Now, by default, it's still using all of the keyframes that we set up in the particles comp, so the size is not really matching at the moment, but we're going to refine all of those settings in just a moment. At this stage, I'm just ignoring any oddities with how the volume looks and just focusing on the movement. So now we can have a look at what's going on here. If we enable this water stream here, and I'll make sure the background plate is behind that. So I've re-enabled the main sim in place of the proxy simulation, but I've just isolated it from all of the other effects. So we'll go into our particles comp controls, and we'll start by ignoring all of these settings. We're just going to remove all of these placeholder keyframes, and we're going to go through each setting one by one and really understand what it does, so that you can create your own custom shots. So we'll start with quite a simple setting, the emission rate. So we're going to start with 5,000, increase that to 8,000. This is for the volume. And the length is looking a bit extreme at the moment, so just while we're just so we don't get distracted, I'm just going to reduce the stream and trail length down to 1.5. Just so we not have a nice congealed blob of water here that we can work with. Ignoring everything else, just deciding when these particles need to be disabled. So it will still render particles even if they're off screen, so we want to make sure we disable them once they're no longer needed. So once the water here, this tab hole, impacts the water, that is the moment where we will disable our main emission rate here. And I think just while we're focusing on the look of the simulation, now that we know it lines up with our plate, we'll just use the grid instead. So we have this width and height, water ball radius, width and height. So we're going to start off with a setting of about 200, as we want it to be a bit thicker. I think we'll adjust the height so that at the beginning, the height can be 200. As it comes out of the water and starts to travel sideways, I want to imagine that the water is being affected by gravity a little bit, so I'll reduce the height to 150. Scrub forward a bit, see what is happening. As the water picks up speed, we want it to stay a more uniform shape here. And then the water is going to slow down and build up into a ball. Whilst it's a long snaking motion, it makes sense for the water to be quite thin, but when all the water congeals into one big ball, we want to convey that volume by having the water then increase in size as it all comes together. So you can, of course, have this volume reduce over time if there is cascading, pouring water. So the water stays as a nice spherical shape until it begins to move again, and that's when we should see our trail become a bit thinner. So we'll reduce that back down to 200. As it starts to be affected by gravity at the top of that turn there, we'll just have it go to 150 instead. just keep scrubbing through here, just get an idea of what's happening. And then as the water comes back down, I think we'll just set that back to 200. So before we move on to the next setting, we'll just make sure we're happy with the size. Okay, so that's the emission rate and the radius sets, and the next thing we'll have a look at is the water drops emission. So for this one, we actually want to enable our water drops. So this time it'll be a little bit slower because we're processing all of those extra drops of water. But we'll just move forward in increments. Set a keyframe for our water drops here. I want it to be quite high at the beginning because it has just emerged from the water. I'll also enable this water flow foam effect as well. That is also controlled by this setting. So as it first comes out of the water, it makes sense that the particles are quite high. But as some of that water begins to fall off the main body, we'll have the droplets reduce. If we have too much cascading water, we'll have to reduce the volume, otherwise it won't look right. But some surface water escaping is fine. So we'll keep going through our timeline here. We'll decide whether we want these droplets to change. They are also affected by speed. So the faster the ball moves, the more water droplets will be spawned. And as the ball starts to slow down, the amount of water will also reduce as well as it becomes a more stable volume. But just as it decelerates here, I want to have the particles spike to get an extra volume of water escaping and crashing into the floor, which it will do when we enable the other simulations. Once we have our our extra eruption of water there, we'll reduce it back down to 5,000. There's no harm in modifying some of the previous settings just as we go forward. Wait for that to cache in. Just decided it would look a bit better if the water was thinner as it moved up there. I'm almost at the end of this cycle, so make a few extra adjustments to the width just as we go forward. This is the process that you have to go through to get an effect that looks nice. It's all about these extra adjustments. And the temptation is to keep tweaking it because the whole thing is a completely procedural simulation. It's not like we have to load up another piece of software if we want to change something. It's just at any moment in time, even when we're compositing, we can just completely change anything, any aspect about it. So that's the downside. We'll be more tempted to keep customizing it, but you have that extra level of control. So now that we're done with the water droplets, I'll disable them as they are a little bit taxing to preview. And we still have other settings that we want to customize with our water ball here. So go back up to the particle controls. So the next effect on our list here is this turbulence amount. So I think it would make sense that as the water is pulled from the surface, that there would be perhaps less turbulence, and then as it picks up speed and becomes semi-unstable, then the turbulence would increase. So the higher this setting goes, the more deformed this volume will become. And remember, that will also affect the lighting, and it will also affect the refractions as well. So we'll just cycle through here, make sure the turbulence is okay. So I think we'll just leave that at 75 for the rest of the simulation. This turbulence speed is a very useful option. When the water is traveling, it's okay if the turbulence speed is quite slow, but when it forms into a more stable mass, I imagine that the surface would be more affected by gravity, and so we'd actually want to increase the turbulence speed when it becomes a floating ball here. Maybe if it's a windy day, it would just make sense that the surface be a little bit more erratic when the water slows down, as all of that extra motion is interpreted by the physics of the water. So once we preview this with the extra turbulence speed, you'll see the difference that it makes. So let's do a preview render, and notice when we do this preview how the water changes when it slows down, how that extra turbulence speed affects it. So this will finish caching in a few seconds, and see the extra turbulence speed really helps to sell the idea that this water is wobbling about. That's a much needed improvement when we have a stable volume of water. That's a very useful setting to know how to use. This gravity effect turbulence is also a very interesting one. We can have the surface of the water constantly be pulled downwards, but we can also have it be pulled upwards. And when the water is initially levitating off the ground, I found that it's quite aesthetically pleasing to reverse the gravity and to actually have the surface tension of the water be lifted upwards. So we'll get to the point where our water is rising. We'll set this to -25. And now the surface turbulence will be traveling upwards with the water. But then as that initial levitation ceases and it becomes a regular floating ball, then it looks nice to have the surface of the water travel downwards to show the gravity. So worth illustrating that. As you can see, the water slowly rises and then the gravity kicks in and the surface starts traveling downwards. And of course, when water is traveling upwards, it's also moving through a turbulence field as well, so having that turbulence field travel upwards with the water will make it look a little less erratic as well. So we'll reset this working range here, and I think we'll move on to the next settings. So for this tip velocity, sometimes it's useful to set this to a higher value, although most of the time I leave it. You can see we made a change and it took a little while for that change to actually be updated. Sometimes the settings don't automatically update, which is why we have this force recache option. So if you change a setting and nothing happens, it might just be a RAM preview error. So if you change this force recache option at the bottom there, that'll force particular to show your update in the viewer. It doesn't change much, it just randomizes the particles slightly. So for the tip velocity, sometimes if it's moving really quickly, you can increase it, but I think most of the time a setting of about 100 or 50 Probably 50 just works better. And unless it's needed, I don't think there's any reason to go keyframing that setting, so I think we'll just leave it at 50. And perhaps towards the end here, where the water moves really quickly, we could try increasing that. I always go for a very extreme value to start with, and then bring it back to something a little bit more sensible. So next we have this spherical field strength. And this is the setting that is responsible for that raindrop tab hole kind of shape that this water takes. It'll actually pinch the front of the water volume. This spherical field travels slightly ahead of the effect as well, kind of pulling the tip of the water towards a point in front. And that's what gives it that nice round sort of raindrop shape. But it can also have some undesired effects, which is because it's constantly sucking the water inwards to a point, when the water slows down into a more stationary ball, this spherical field will actually shrink the ball slightly as well, because it's pulling all the water into the center. So when that does happen, we no longer want this field to have any effect. We'll just set it to 0, and we can see our ball just increases a little bit there. It was quite important in this tutorial to show how to set the particle simulation for both moving water and also hovering water. So having this moment where the water slows down allows us to understand what these settings are doing a bit more. So as the water begins to move again, we'll have our spherical field slowly increase in strength. And we'll just adjust these keyframes a little bit. So we're almost done with the particle controls. There are just 2 more settings after this, the stream length and the tail length. And that's going to allow us to decide whether we want this to be a tight congealed blob of water, or if we want it to be more of like a long stream of water. This value of 1.5 seems to work quite well. We'll just finish off with the spherical field here. I think as it moves really quickly, we can set it to -10 there. So let's begin with our water is emerging out of the ground. Let's increase the stream length and tail length, so we get a much longer stream of water in the beginning here. And then once the water comes out of the ground, that's when we'll reduce the settings back down to perhaps 1 or 1.5, I think worked best before, so we'll keep that at 1.5. See the difference that would have made though. Could have a very small stream or a longer stream, but I think having it a little bit longer just helps sell that sort of fluidity. And when you think of the amount of changes and tweaks we've just made in this short span of time, and if you had a completely different design in mind, a different shot, different movement, all of these techniques that we're learning here will give you the tools to be able to create your own custom simulation that works. As the speed increases at the end here, it does get a little bit erratic with the length. So as the water really starts to pick up speed, I think we'll compensate for that and reduce it down to 1. Maybe even reduce it down to 0.5 because I want it to be quite a almost like a water ball impacting the surface rather than a stream slowly trickling into the surface. So as long as it has conveys that kind of impact, so that's the difference that seems to be making. So this last section here I think might need a little bit more attention because as it swoops around there, the tail of the water is being affected by momentum. So if we go into the water stream here, and keep the workspace, we'll hide the layers that we don't need just so the working space is a little bit easier to interpret. I just enabled the motion blur settings just now, so that's obviously slowed things down a bit. And actually we've just re-enabled all of the effects, so we can just have a quick look at this. So as for that tail of the water, we can go into particular and we can just reduce the velocity from motion if the water looks like it's spiraling around a little bit too much. So then we'll go to the export comp and we'll drag our footage or resize it to fit the comp, and we'll just wait for that to load in. We'll take a snapshot here just so we can illustrate what will happen once we copy our footage into the reflection comp. So that's what it's doing to our footage to generate the reflections. So you can see the water will immediately start to inherit some of the lighting in the scene, although it's a little bit too intense at the moment. And since we're going to make a bunch of adjustments in the export comp, I'm just going to disable the motion blur for the main volume, as that is a little bit slow. So let's also take the time just to take a snapshot of what this looks like at full res, just as a reference. So I think what we'll want to do is bring down some of the lighting that we have on the ball here. So we have this inherit scene reflections. Let's reduce that from 25 to 15. And we'll use our snapshot to compare the before and after. I do like the water to kind of be a little bit darker, so we'll also bring down this Frenzel shading as well. That will brighten the edges of the water, taking off some of that extra sort of brightness there. The water's getting a bit darker. I'll take a snapshot of that, and we can also experiment with the amount of refractions. So we have the wave height here. So if we increase that to maybe 50, has quite a big effect. I'm not in favor of that effect though, so I'm going to keep the refraction height rather low. We'll try 10, although that might be a little bit too low. It does have quite a big impact on how it looks. I think I actually preferred how it looked on 15. It just had a nicer sort of glassy effect to it, so I'll keep that at 15. We have options for how bright the water is, the reflection strength. So we can make adjustments to all of that. We can also change the scene color here. We could just borrow the color from the sky. It's probably going to make it a little bit blue, so we'll bring the tint down. Might bring the turbidity opacity down a little bit as well when it's first coming out of the water. Turbidity opacity is like how cloudy the water will be, how sort of can affect like the darkness as well. As light passes through water, it does refract and become darker, hence how when the water is floating in the air, it actually looks quite dark because the light that passes through it is slowing down. So we'll just make a couple of keyframes here. Really all I'm going to do is just bring down the opacity a little bit at the beginning, and I'll also bring down the specular highlights at the beginning as well. And then once the water is fully immersed, I'll reset the specular highlights back to what they were. So maybe we'll be going from 50 to 75, just a small change. Best advice is to try all of these settings, try an extreme value. If you don't know what turbidity brightness does, try 100, then try 0, take a snapshot and toggle between them, and that will sort of inform you what the setting does. So I might bring the Forensal shading down a little bit more as well. I don't want the water to look too bright. Well, even though it's a bright day, it's not that bright that the water will be glowing, so I think we're getting a nice result here with the refractions. So the water is actually taking our simulation, generating a normal map from the water simulation, and then it's using that normal map to generate these refractions and everything like that. So once we're ready to move on, we'll re-enable the motion blur settings for the water. Always worth making sure they are enabled. And we can see the before and after with and without motion blur. So this will help with the movement as the water is zipping across the screen. We also have this little ripple asset just as a placeholder. There are other ripple effects, for example in the Rising Water Ball project. There's a much larger ripple asset that we could always borrow. So we're going to render this, use it as a pre-comp before we move into creating ice. So we'll render this as a QuickTime file. Give our project a name. So we'll click save and we'll render that at full res with motion blur. It was quite a long shot and it took about 4 hours to render, so that was fairly expected for a shot like this. So next thing we'll do now is we'll move into creating our ice. So we'll go into the ice formation project. When you first load up the project, you're met with this kind of preset. So we're going to understand now how we can change this ice and completely customize the shape of it to match what we're doing here. Let's have a quick look at what our water looked like. So with the motion blur, have our water, all the cascading droplets, then impacts the floor, and it's ready for us to add our ice effect. So that turned out rather nice. So we'll start with the just enabling the proxy simulation for the ice here. We also have this emitter animation. We'll want to make sure we can see that as well by checking the unhide layers. we'll just get to the timing where we want the ice to actually start. It'll be about here, so just Alt left bracket and just cut the clip there, just so we have a reference on the timeline where the impact starts. To move our ice forward, we'll just grab all of the keyframes in the project, we'll just shift them forward. And then we can adjust our emitter animation here. There's 2 keyframes. So if we just adjust the first one so that it starts near the base of this water impact, and just adjust the second keyframe so that it's going directly up. We also have this global emission locator here. So this allows us to move and rotate the simulation without actually changing any of the properties. If we go into the particle controls here, we do need to set a keyframe to be 0 at the beginning to make sure the ice doesn't spawn until we want it to. This ice effect is a little bit slow, so we're not going to worry too much about trying to time it up perfectly. We're just going to get the animation the way we want. We'll pre-render it, and then we can speed it up and move it forward if it's coming in too slowly. So as we moved our emitter animation upwards, we're getting more of a sort of directional blast that goes upwards instead of sideways, which is a bit closer to what we want. So the faster that moves, the higher the ice will actually climb. That's quite an organic way of changing the simulation. We also have this ice deformer sphere, best illustrated as we move this around. It'll suck the ice towards it. That's what allows us to create like a bending ice effect where it kind of arches over. But if we put that below the water, it should work just fine. So this emitter animation is actually using a spotlight. So not only will the position and the speed of which the position changes affect the simulation, but also the point of interest, or which direction that the cone of the light is facing. So if it travels upwards but the light is facing, say, to the left, then that'll also impact the direction of the ice spikes. So as this is a simple upwards blast, we want to just go to the orthographic views here and make sure that this light is not only traveling directly upwards, but also that the point of interest is also following the path that we want as well. So we'll just make sure that the light is always facing upwards, not sideways. Go to the front camera, make sure that we've also have the same uniformity as well. See, in the placeholder animation, that light sort of arches around in an animation, and that's what allowed it to have that sort of arched over look to it. But this is just a straightforward ice blast going upwards. I'm thinking of the type of ice blast that you might see from like Frozen or something. So in this active camera view, it's less confusing now. We can see that it's a wide facing cone that just moves upwards. If the ice is going up too quickly, we'll just bring that down. Of course, if we adjust this cone angle, that'll also change the formation as well. We have our velocity from motion, so the more velocity from motion we have, the faster the ice spikes will move up, and we can get a more dramatic explosion like that. I think in future I'll create more presets for the ice, ones for very short, quick blasts, another for like a longer, slow growing formation. Because there are quite a few settings here. There's so many different ways that we can influence this formation of ice that can sometimes be a little bit overwhelming. And then just the power we have to customize this. We could just sit here all day just using these settings, but randomizing the simulation until we get a setting that works perfectly with the shot that we have. Again, since we want the ice to kind of move over to the left a little bit, if we adjust the deformer to the right, it'll kind of give the ice the sort of illusion that it's sort of pushing to the left a little bit. And of course, this being a nice 3D particle system, we can adjust the light position as well. We'll adjust that, we'll see the shadows change. It's kind of baffling the amount of control we have in After Effects to change this. There's so much more potential for this technique as well. We create so many different effects with this. But we'll save ice for a future video when we have more settings. So we want to pre-render this asset now, make sure it has an alpha channel. And that way when we bring it back in, we can time remap it, we can have it expand faster in the beginning and make sure that the timing matches up perfectly with the moment that the water impacts the surface. So at full res, with all of the settings, that took about an hour to render. But when you see the result we get at the end of this video, like an hour to render this ice will just seem like nothing. Even if you do spend half a day working on a shot, rendering effects like this, the most important thing is that you have something really aesthetically pleasing that you can show at the end. So I brought in this ice here, and I'm just going to right click, go to time settings, and just increase the speed by 50%. And so now we're getting a nice kind of impact. Might need to bring this ice forward just a little bit. I've also enabled time remapping, and I've just made it so that the ice explodes really quickly in the beginning few frames and then slows down a little bit. Okay, and then we can move into the export comp, and there are a few settings that we'll need to change here to get this ice to match. So it's definitely not working initially with the standard settings, so let's help this out by selecting the correct color. Sample the sky here. The ice would be scattering some of the effect from the sky. It's going to help take us from our sort of brown looking ice to more blue. Let's also try flipping the specular height as well. See if that changes the specular here. So that can be quite interesting. These refraction effects here, these can have a pretty dramatic effect, especially the vertical refractions. Changing the vertical refractions to -200 will dictate whether the ice pulls light down from the sky or whether it uses the water, the lower part of the image, to generate the refractions. So this way it looks like it's connecting with the darkness in the scene. If we enable the hidden layers, go to the ice refraction adjustment here, we have this compound blur. We have added the settings that we're going to be changing here to the compositing options, but in this tutorial we're going to change them manually. So by changing the maximum blur, we can bring in those that compound blur a bit, so more of the background is visible. We'll also check this invert blur here, and that's giving us nicer refractions on the edges. I'll also disable this CC repeat tile and enable mirror edges here. And look at the difference that has made. we're getting that really nice refractive edges on the ice. Keep using the snapshot here. Sometimes I just like to turn off a layer to see what it does. So that's just adding a little bit of extra color there. So it's the shadows that I want to reduce. After making this tutorial, I made sure that there was a slider for the shadows, so you'll see that option in the compositing options there. So bring the shadows down. Also just gonna brighten up some of these effects here. So we've got the illumination. I'm just going in, putting curves adjustments to make things brighter. Bring that luminosity up a little bit, try and match the ice in the background if we can. I'll lock that layer while we're in the export comp. That will allow us to go into the particles comp. And I might even try just putting a little curves adjustment on the particles and just see what happens when it filters through and makes its way back to the export comp. So that's a little bit over the top. Let's try and keep that contrast and just make a really subtle adjustment to the contrast of the ice. And if you can't decide if a setting is too much, we can just go to the compositing options for the curves effect, set it down to 50%, and then we'll just get a more toned back result. So that is brightening up the ice a little bit more. Back in the export comp, let's just go forward, and been staring at one frame for a while. Let's go forward and make sure that the ice is okay on the other frames as well. So it might be the case that the diffuse lighting here, if we add a curves adjustment to that as well, we can brighten it up even more. Yeah, I think having the brightness more towards the end there, I think is really helping. The ice in the scene is very illuminated, so we also have darker parts of the ice as well. Let's take if we go into the compositing effect opacity of the compound blur and we reduce the compound blur, it'll actually clean up the ice a bit more, and we'll transition it from black ice to more like crystal ice. So that's a very powerful effect as well. Again, all of the manual adjustments that we made here in the tutorial I decided to turn into sliders as well. So you'll see, I think it's ice cloudiness opacity will be the setting that reduces that compound blur, gives the ice more of like a glass look. So all I'm doing at this point now is just checking the opacity of some of these shadow layers, just making sure the ice doesn't look too dark or bright on different frames. And with any luck, we'll only have to render this once. And what we'll do now is we're going to create a sheet of ice to go underneath our ice blast. So I've just pre-composed the footage, and we're just going to work on this as its own separate comp. So I'll start by creating a fractal noise effect on a layer here. We want to add this sheet of ice in before we actually render the ice, because it'll be very difficult to composite anything behind the ice with the refractions. So going into the fractal settings here, we're just going dynamic. We're putting a vector blur with the amount of 25. It's giving us a nice caustics effect, but messing up the edges. So if we just, whenever the edges get messed up, you just create a motion tile effect. Or you could use a CC repeat tile, or you could go to utility and grow the bounds, but most people use this motion tile effect here. Seems to work quite well. We'll duplicate that fractal ice we just created, and in the second version we'll change the fractal type to threads. We'll put the contrast way up to 1300 and the brightness down to about -800. We'll go into the transform settings here, reduce the complexity, reset this vector blur, and I think we'll put it up to a setting of about 75 here. This is going to be the specular highlights of our ice, so we don't want it to be too bright. And then if we go to the sub settings and we start increasing the sub influence, we get this very interesting pattern here. Now, we don't actually have to worry about the edges, it's only messing up because of our plate. Once we remove the plate, set that layer to lighten mode. So this is the ice texture we've created. So we're going to pre-compose this into a single ice texture that we can use. Then we can enable our plate, turn the ice into a 3D layer, and we'll just rotate that. I think you can guess where this is heading. We want a nice big texture of ice to grow over the water to really help sell the fact that there's ice in our scene. So we'll position our texture so that it covers most of the water. And now it's just a simple case of creating an elliptical mask, using Control left click, get a nice setting that works well with the perspective. We'll want a lot more horizontal feathering than we do vertical feathering. And then we'll put this roughen edges effect on top of that, which takes our feathering, roughens it up. We'll increase the border to 32, whack the sharpness up to 10, so we really get that cracked ice effect, and increase the stretch width to 0.5. And then we can just use the mask expansion options here to grow our ice over time. And as we change this setting, we can see it's expanding out there in an interesting way. You can always set that keyframe to an ease keyframe so it slows down towards the end. Let's just quickly preview this. We'll have that big blast of ice, and then all of this surface ice will freeze the water. I think at the beginning here there's the ice is too broken up, so we can just keyframe the feathering, bring that down till it forms a more concise shape, get rid of that splattering pattern just by simply changing the opacity and keyframing that over time. Okay, so that's working okay. So now we can start taking this to the next stage. We want to pre-compose this layer again because we're going to use it as a displacement layer. So for this first layer, we'll set the blending mode to luminosity. As that's having an interesting effect, we'll put a curves adjustment on that. And we'll play around with this. We'll duplicate it again, set it to screen, and we'll bring the highlights down so it's not too high. We'll also add a tint effect. We'll just sample the watercolor a little bit. And then finally we'll duplicate it one more time, and this will be for the very bright highlights. So we have shadows, midtones and highlights, so we'll just extract the bright bits that we want. Black point to 165, black softness to 92. Then we'll add a compound blur, just put a setting of 1. We'll reduce that opacity down to about 25 here. So play around with the luminosity setting there as well, just to get those values where we want. And we don't want it to be too dark and we don't want it to be too bright. And then finally we'll duplicate it one more time and we'll just rename this to alpha matte. This will have none of the effects and will just be used as a matte for our adjustment layer here, as we're going to add a little bit of extra refractions. So if we add a motion tile to begin with, then we'll go to distort, displacement map, and we'll choose our ice texture. And so it's making the ice look kind of 3D, which is interesting, but we actually want to try and get that more glacier kind of effect. Increase that, and then to get rid of the noise, we'll go and add a median blur here. Set that to 2. Unfortunately, that affects everything, so that's where our alpha matte comes in. So that's our ice texture. It's giving the ice an interesting sort of refractive property to it. So that's not too bad, just for fractal noise. Make a few, darken it down a bit, try and get some of those reflections in there. And then let's preview this. So, remarkably, that is working first time, so now we're going to, since we pre-composed our plate, we're now using that ice sheet will go underneath the Ice Blast. What I've done here is I'm just duplicating that diffuse lighting, renamed it to reflections, and we're just adjusting this. We're going to create some basic reflections with the water here. So making sure it lines up. In the reflection layer here, we're going to, while we're working on it, we'll put it to 100%. We'll create a feather mask here. Set that to 600. And then if we minimize all these effects, get rid of the curves adjustment, and we're going to add a CC glass effect. And we'll set that to use the background plate that we just made. That's the one that has our ice flow sheet in it. Set the softness to 4, height to -25, the displacement to 350. That gives us that water ripple effect. Add a motion tile, just in case anything funny happens at the edges. And we'll also add a medium blur here just to soften out those reflections a little bit. And then finally we'll create a turbulent displacement, and to add some movement into the waves, we'll set this to horizontal displacement. Set the amount to about 190, the size to 5, and the complexity to about 3, and make sure we set the anti-aliasing to best settings. And then if we just add some expressions to the time here, the evolution, time times 150, we want the offset turbulence to do something like that. So Alt left click on the offset turbulence, open brackets 0, comma, time times 15, close brackets. The first setting will be set to 0 and the second setting will be affected by time. And then if we go forward, and it's just enough to sell movement on the water. I found water reflections to be pretty tricky actually, but it's just about sells the effect. So, and then finally we'll just add a photo filter with a simple cooling filter, and it's just enough, especially if we lower the opacity. And in order to create the glow effect that you see on the ice at the moment of the impact, it glows a kind of cyan blue colour. To do that, all we have to do is duplicate this diffuse lighting layer here. We'll add a tint effect and just sample a colour of the ice in the background. Give it a little bit more blue. Then we'll change the blending mode to additive. Rename that to something. It's looking a little bit sharp, so to bring the softness up, we'll add a compound blur with the default settings. And then we'll just press T to bring up the opacity, navigate to the correct frames and start putting some keyframes down. So I'll keep the opacity at 50 just so it doesn't get too bright. Go forward a little bit more, put another keyframe down, and then forward a bit more and keyframe the opacity to 0. So we just end up with a quick flashing animation. And if we play this back, we'll be able to see it adds a nice extra flare. Kind of makes it seem like magical ice, and it's just a nice extra effect that we can add on. I think we haven't really had a proper look at this yet, so as you can see, we created that ice sheet. And if we look at this at full res, it really helps just to integrate the ice onto the water, because you'd think would the ice fall through the lake or float around, but having that big frozen sort of effect just helps, you know, make the ice seem plausible that it's stationary there. And of course, if you want to go make frozen, you can go do that as well. So we'll render this out. First we did the water, then we did the ice, and then we added our ice sheet, and then when it all comes together it looks something like this. Okay, we'll wrap things up there. Make sure to download Trapcode Elements version 1.2 to get access to all of these new water shaders. And be sure to check out the other videos in this tutorial series where we have already covered all of the other elements like fire, earth and wind. Stay tuned for more content. Good luck with your projects and thanks for watching.